voltage under non-standard conditions. At the end of this lesson, we are expected to be able to compute cell voltages under non-standard conditions and to calculate the concentrations of ions using Nernst equation. We have learned how to calculate the voltage of cells under standard conditions in the previous lesson. So we recall that when we say standard voltage, we mean the voltage when gases are at the pressure of 1 atmosphere and species in aqueous solutions are at a concentration of 1 molar. And of course, the temperature is 25 degrees Celsius. However, in reality, when a cell is discharged, so when you use a cell, diba, standard conditions are not maintained. So, kanang 1 atmosphere nga pressure o kanang 1 molar nga concentration, dili na siya ma-maintain as the reactants are consumed in the process to generate the products. So, meaning di ay, kung non-standard ang conditions, ang concentration of the aqueous solutions change and the pressure of the gases, they also change. O kaning duha mo change. Now, the question is, what will happen to the cell voltage if the concentration of the solutions are not 1 molar or the pressure of the gases are not 1 atmosphere? So, unsay mahitabo sa cell voltage kung dili na 1 molar ang concentration sa aqueous solution, kung dili na 1 atmosphere ang pressure sa gas? Okay, so when the concentration of the reactants and products change, the cell voltage also changes. So, of course, ma-affected sa ang cell voltage. As the reactants are used up and the products are formed, as the reaction progresses, okay, here it is. The cell voltage changes according to the change in the concentration of the reactant. So, adto ta tan-aw sa reactant. And the relationship, cell voltage is directly proportional to the concentration of the reactant. Meaning, ang cell voltage mo increase kung ang concentration sa reactant kay mo increase. Ang cell voltage kay mo decrease kung ang concentration sa reactant kay mo decrease. In 1888, Walter Nernst proposed the relationship between the cell voltage and the concentration of the reactants and products. This relationship is shown using the formula called the Nernst equation. So, kani nga relationship gipakita or kani nga equation or formula gipakita niya kung unsay relationship between the cell voltage o concentration sa reactants o products. So, kung kani ang cell voltage, ang diri sa pikas, ang Q ang ni-represent sa concentration sa reactants o products. So, E here is the cell voltage. Of course, we're still going to use the cell voltage under standard conditions. N here is the number of electrons transferred. So, as I discussed in the previous lesson na to, nga ang kadong number of electrons transferred, kay mo na tong number of electrons nga na-equal sa duha ka half reaction sa oxidation or reduction. And Q here is the reaction quotient. So, again, muna siya mo represent, diri na to makita ang concentration sa reactants o products. Reaction quotient. What's ang reaction quotient? So, the reaction quotient is a measure of the relative amount of products and reactants present during a chemical reaction at a particular point in time. So, at a specific time. So, it's a ratio of products over reactants. Okay? So, for example, muna siya ang given nga chemical equation. So, substances are the capital letters A, B, C, and D. So, these are the different species. And the small letters A, B, C, and D are just the coefficients used to balance the equation. So, to find Q, or the reaction quotient, all we have to do is to multiply all we have to do is to raise the concentration of the product raised to the coefficient, multiply that to the other concentration of the other product raised to the coefficient gapon. So, it's concentration raised to the whatever is the coefficient here in the equation, i-multiply na silang tanan. Basta this is product over reactant. Okay, so that's products over reactants. The capital letters, again, as I said, represent the concentration of the species in the reactants and products, and the small letters, the coefficient in the balanced chemical equation. The reaction quotient Q is written by multiplying the concentrations of the species of the products and dividing the concentrations of the species of the reactants. So as I said, products over reactants. If any component in the reaction has a coefficient, the concentration is raised to the power of the coefficient. So, muna akong giingon, nga concentration ni C raised sa iyang coefficient C times concentration ni D raised to sa iyang coefficient nga D divided by same gihapon sa reactants. In the formula, however, in the formula in finding kaning Q, we must keep this in mind that gases enter Q as their partial pressures in the atmosphere. So the unit is atmosphere also here. Species in water solutions enter as their molar concentrations. So molar, capital letter M. And so mura na silang duha ang mo-enter sa equation. Gases and species in water solutions, so meaning aqueous solutions. Kung gani ang species nga present in the reaction na makita nato sa chemical formula or chemical equation kay pure liquids and solids, they are functionally omitted in the expression. So dili na nato sila apilon sa expression kay understood na nga 1 kay nga naman their concentrations do not change kay pure solid and liquid man. So dili na mo change ang iyang concentration. So for example kani nga equation, so we see here that species A is a solid, species B is an aqueous solution, water solution, species C is, this is actually aqueous, and species D is a gas. So to find Q, so it's products divided by reactant. But we do not include A in finding Q because it's solid. So solid is not included in the expression. So, for molar concentrations, we use actually a bracket for the concentration. Meaning, kung bracket na gani gigamit ana, meaning it's an aqueous solution. So, C raised to the power of the coefficient niya nga C. And if it's a gas, we use the parenthesis. So, D, the pressure of species D, which is gaseous, raised sa iyang coefficient nga D, divided by the concentration of species B in the reactant raised to the exponent niya ang ihang coefficient nga B. And as I said, walay labot si A because it is a solid. So gas ra gyud og aqueous solution ang apil sa pag-find ni Q. Okay. So how do we interpret Q in the Nernst equation? So di ba ang Q kay product over reactant. Okay? So if Q is greater than 1, the concentration of the products kay greater than the reactant, di ba? So kung greater ang concentration ni product and reactant, ang cell voltage under non-standard conditions kay less than siya sa cell voltage under standard conditions. Baliktad, no? So baliktad ni siya. But if Q is less than 1, meaning the concentration of the reactants are greater than the products. Kay less than 1 man, mas dako ang denominator. And if that is the case, kung mas dako ang concentration ni reactant kaysa ni product, meaning ang cell voltage under non-standard conditions kay greater than the standard cell voltage. And if Q is equal to 1, then the concentration of the products and the reactants are equal, then therefore the cell voltage under non-standard condition is equal to the cell voltage under standard conditions. Okay.